boss of the socks. Let's start with the USB key. And here, you go to registry, and then USB keys are plugged in. They have a friendly name, so this is probably the much easier than it used to be. So if I go here and see what source types exist, one of them is going to be registry events. And this is something I talk about in the forensics class. There's a registry record of every USB device that was ever plugged in, which is extremely useful for a forensic analyst because it shows you what storage devices you should subpoena that will have it. And if it's a USB stick with a name, it'll have a friendly name, which is a name that you normally think of it, like its volume name. So now if I search for all time, there's only 2 such events. And so if I make this a list, and there it's friendly name, and you can see right here, data is Miranda Pry. And I think that's it. I think this is the name. It's all modeled on characters from that movie. Miranda is a character that betrays the Batman, and so that was the source of the infection. So they plugged in this USB stick and then ran malware. So now Bob Smith's workstation is what it was plugged into, and that was connected to a file server. So we're going to find Bob's workstation. Now for that, we're going to need Bob's IP address. So let's do that one. And that's why I added a note saying make sure and keep notes as you go ahead because you're going to need some of these for later. So we do this one again. We're going to find the IP address of this guy. So we want to find, we want to use stream LDAP and search for We8105 desk. So I guess I'll turn on some event sampling for now and do this. All right. And then stream SMB is the source type. Here it is. Stream LDAP. Okay. Now I'm down to a small number of events, so I can turn off the sampling. And now I just want to find events on that day. Let's see, if I look at the source, I only have 74 events. If I look at the source, that's the source type, all from stream LDAP. All right, find events on that day and look at their IP addresses. Let's see how many IPs I've got here. Source IP or something like that. Source port. Well, destination IP. Good, the destination IP, that's going to be the domain controller. Source IP would be somewhere. I couldn't find it. You found it?
Yeah, keep going back right there.
Oh, source IP, there, good. Yeah, so it all came from here. So this is the IP address of Bob's workstation. That's something we're going to need. All right, let me throw that in here. All right, so now that we have that, let's go down to, we want to find the server names. We want to find the SMB stream data for Bob's workstation during the outbreak. Now, we'd like to know the time of the outbreak, so let's do that. I remember that from before. If I go back to a plain search, and I turn on event sampling again, and go here, and I go to Suricata, I can find the exact time of the event, of the ransomware outbreak. So I go to Suricata, which I don't know why this thing can't handle being a different size window, but it can't for some reason. All right. All right. So there's Suricata. Now I go to all time, and now I add the word server and turn off the sampling. And I should be a total, and there's 5 of these events. So now I get the time of the outbreak. It started at this time, 8/24/16 at 9:49, and it ended at that time. So that's the time range of interest. I'm just going to copy it. I think I already got it in notes, but I'm going to put it in here again. All right. There's the start of the time range of interest. And here's the end of the time range of interest. This period of about half an hour is the time at which the ransomware outbreak took place. All right. So now, how do I know that?
How do you look at the range?
Because these events are when it first detected Suricata, and you can tell from the alert signature. So the first 2 are server check-in, which is the signal it sends when it first starts, And the onion domain lookup is where it looks up the ransomware note to post it. So you know it's done when it does the onion domain, and it starts from the check-in. So that's just that's how it works. Good? All right, so now I'm going to find SMB data for Bob's workstation during the outbreak. So let's go back to a clean new search, and I'll turn on sampling again and get my data summary. And I want SMB because Bob was connected to a file server, and he encrypted all the files on the server when all the ransomware ran on his workstation, which is what it does. So I get stream SMB, server message block. This is Microsoft's file sharing protocol. And now I want to be on Bob's workstation, so I want to have this IP address in there. All right, and let's see how many events I have. If I turn off event sampling, I still have 0 because I haven't got it all time here. All right, good. Okay, so I have thousands of events, so I really would like to limit the time to the time of the outbreak. So let me see if I can do that. It's a little bit clumsy to do a time range. Date and time range. Okay, so it's going to be from 8/24/16 between 8/24/16, all right, and here, and it's going to be between this time, 9:49 and change, and this time, 10:15 and change. There, if I apply that, then I get down to 6,800 events, which is, and looks like it's true because this is 5:05, 5:06, 5:07. Yep, this whole time range is now about half an hour. So I've got SMB for Bob's workstation during the outbreak. Now I'm going to add path equals star, so I only get ones that include a path because the path is if I look down here for the path, you'll see path is not showing. Here's path. I'm going to make it selected. All right. Now it should be in the top list. Path, there we are. See, the path shows the path to the thing. And so these are the ones that are going to shares. So I don't want ones that don't have a path because they're not really events that are accessing a file share. So I add this. That'll give me events that contain a path, and there are only 21 of them. All right, and now I can see what the question is. So I want to find which file server he was connected to. So I look at the paths. All right, and this is obviously it, we9104 server. His workstation was named we number Bob or something. So this is the one. And here's another way. Several of these, in fact, they're all going to the server. Most of them are. So that's the name of the server. And so we know what server Bob connected to. All right. What's the IP address of the server? I think we've got it here. I think it's this, although I guess I don't really know that. I tend to think it's probably that ending in 20, but let's see what I say here to find it. Search for the server's name, get the source of these events. All right. And I guess I'm thinking one of these will probably do. Let's just try one of these. If I go and examine this, examine one of these. This is the one with 192.20. Let's go to the one that has the server's name in it. There, this one has the server's name in it, and I have the destination IP there which matches. So I'm pretty sure that's it. That number ending in 20 looks like that's the IP address of the server. All right, so I want to see how many PDFs the ransomware encrypted. So I search for PDF, and I want to find out let's see what I get if I do .pdf. And by the way, I probably do want to be only during this time range. That's when it happened. That won't hurt anything. All right, I have 857 events about PDFs. Now I want to find app. What app was accessing these things? And there it is. And the unknown app is the one that did the encryption. These others are harmless things, like Microsoft services. So I want the unknown one, which still gives me 524 events. And I want to find all unique file names. So I've already controlled the time range, so I can do a table of, say, file name. I think it's file name. Let's see what the name of this field is. All right, where's file name? Not there. And not there. Let's see if I can find it here. Let's search for PDF and see if I can find out what it is. PDF. All right. Okay, it is relative target name. Okay. There. Yep, those are the things I want, those names there. So I'm going to copy this relative target name and make a table of that. All right. See how that looks. All right, it's pretty good. And now if you're worried about duplicates, which there might be some of, I think you can supposedly dedupe inside Splunk. I didn't have a lot of luck doing it. Is it dedupe? I have 524, good, just dedupe on the same thing. So I have 524, that number should go down. Oh, and it did, no, it did not go down. So I don't know, maybe there weren't any duplicates. I'm kind of skeptical, but I guess that's probably right. Anyway, that might be it. If not, I would export it to a file and use like the unique command in Unix to really make sure. Anyway, so that's the thing there. Now you want to find the VB script found above. It launched this thing, so I'm going to find the parent process ID of this program, which launched temporarily. So I'm going to search for this and look at the event description field. This is one of the processes involved in the ransomware. And so I think being restricted to this time range is probably still good. I'm in the time of the ransomware infection. But I guess maybe not. Maybe I need to be a little bit outside. And it's supposed to find 190 events. All right, let's go to all time. All right, now I have 190 events. Examine event description and see if you can figure out which ones came from the ransomware. Oh, only 4 types. Image load, file create, process create, and process terminate. I imagine it's probably file create, creating the encrypted files. Let's see what we're looking for. It launched one of the parent process ID. Examine the command line field. Well, but what we're looking for here is a process create. We're trying to find the parent process that launched something, so that's probably a process create. Let's try that. Process create, and now command line. And there we go. This is what launched that program, 1214.temp, and this is what launched the C Windows C to start. I think that's probably what they wanted for the parent. The question is, what is the parent process ID of this initial launch? And I think if you go to this one, which launched the program itself, the parent process ID will be one of the fields. Yep, there's parent process ID. All right, so it'll be one of these values. I guess there was more than one event. Yeah, 2 events. All right. And so it'd be initial launch, it'd be the earlier time, I suppose, would be the one to get there. All right, now we want to see how many text files did it encrypt. So we'll do text and find the path to Bob's Windows profile. Let's start with text and see how this looks. And then look at path, which might be relative file name or something. Let's see. Relative target name, probably. Decrypt my files.txt. That's clearly something the ransomware did. Let me see. I got the text. Now find the path to Bob's Windows profile. I'm not sure it's going to find it in this relative target name. Let's see. $4,000 events. I don't know if this is the best way to find it. If I sort, am I going to find anything good this way? Temp, file, Nessus. I'm not having any luck. Maybe I need to add Bob. Bob's Windows profile. It'll have users in a Windows profile name. Let's try adding, let's get out of this. It's not the relative target name. It's going to be some other field with the path. Windows profiles are in roaming profiles. The word roaming will appear in it. If I search this page for roaming, I should find a Windows profile. Not on the page. Let's add it to here then. It's in here somewhere. Yep. And now it'll be in here. All right. That's it. Wayne Corp, Microsoft Paths, Microsoft Windows profiles always have this roaming in it. So it's C users, Bob Smith, Wayne Corp, Inc., app data roaming. So that would probably be about enough to make sure that I'm seeing events that come from Bob's profile. So I can probably add that here. And I probably need to double these. All right, that should be text files in Bob's profile, 411 of them. This is looking much more reasonable. Examine the file. Okay, now I'm just going to find how many events. So in your find the file paths, which maybe this is now the file path. Okay, there they are. That's what I want. So I want file path, and I want to remove the ones that are not in his profile. So I do make a table of these. There we go. And now I see these are things in Bob's profile getting encrypted. If I sort by file path, these 4 are not in his profile, but these are. And if I go all the way to the end by sorting again, here, even the ones at the end are. So I know all I have to do is take this total number minus 4 is the total number of files that he encrypted. And by that, I suppose there could be duplicates, although I don't think there are. We can check this. Dedupe on that. 411 goes to 411. Yeah, there were no duplicates. All right. All right. And so it downloads a file that contains the cryptor code. We're going to do HTTP downloads for the suspicious domain. We found it in a previous one. It was solidarityproximity.org was the domain. So we're going to find downloads from that domain. So we go to a clean search and get HTTP downloads. There's a lot of them. So I'll turn on the sampling and go to source type HTTP. All right. And it's going to be solidarity proximity. That's probably enough. Solidarityproximity.org, I remember it. 0 events. Let me check my notes. Maybe I spelled it wrong. I think I saved it here. Nope. All right. I'm going to have to go back and get it. Solidarity. See if this helps. No. Oh, sampling. It's probably been working all along. Okay. Nope, still 0. Okay, what have I done wrong? All right, I have to go back to 4.4. I thought I knew what I was doing here, but apparently not. Find Suricata events on 24 August. Examine source IP, We8105 desk. That's Bob. Bob's address is this, I think. So I want to find Suricata events. All right. Find out what's going on here. Suricata events. Yes. All right. Some kind of failure to scroll in Opera anyway. All right. Suricata events and all time. All right. And I want to find them on 24 August 2016. And that will go, I think, from, not before, but between. Okay. I erased it just to irritate me. All right, and this would be between 0 and, say, 2359. That should be pretty much all day. Apply. All right. Suricata events, source IP. There it is. And we want the one ending in 100. This is Bob. All the rest of it is other things. And we want event type. All right, HTTP. All right, we're getting there. Now there should be a malicious host name that stands out in the host names visited. HTTP hostname, there we are. So there it is, solidarityproximity.org. Now, why did it tell me there were no such events matching this when I tried to do this before? I thought I had it right. I must have fouled it up in some way. All right. Okay, search for HTTP downloads from that domain. All right. So I go up here and I get clean search, go to HTTP, all right. HTTP is here, and I want all time, and I want that domain. And it shouldn't give me 0. One event. All right, now I feel better. I don't know what I did wrong before, but there it is, getting the file. You can see it right there, mhtr.jpg. And this is a well-known thing, by the way. It always uses the same file name for this ransomware. If you want to read about this, in fact, you can just Google mhtr.jpg and server and find write-ups like this, Anatomy of a Ransomware Attack. This will explain how it goes. And this, I think, is the last flag. You can read about this. It actually hid code in this image and then extracted it from the image. And that's steganography, where you hide one kind of data in another file. An unusual procedure used by this ransomware. Anyway, and that's here. So that's it. That's the last several flags I wanted to show you. And let me stop the recording.